We're going to give you a very brief update on what's going on in terms of modeling. So you've seen a variety of data sets. Numerical modeling plays also an important role within Delta X, and this is just a short, very short update on some of that. But essentially, we're using all the data sets that you have seen this morning. They get integrated into the models. We calibrate the models with the field observations and with this data. And then the models are very important because they allow us to move forward in time and understand what's going to happen essentially by 2100. And so I have two recommendations. One, for those that are tuning in that may not be familiar with these models, there was some extensive training done at the Open Data Workshop last year. So I would certainly recommend checking out those because there's various training being done. The second is that these model results are not going to be at the DAC yet at Oak Ridge, and that's because we're still calibrating the models, and you will see that. So both from the JPL group and from my group at UT, but you should keep in mind that for those of you that are interested in browsing some of these modeling results, there is a data download page on the Delta X website where we place preliminary results, particularly those that we present at various conferences and things like that. So there are already some data sets to browse through. So at UT, we've been using Anuga. JPL does use Anuga as well. This is an open source model. It has a bunch of advantages that we can discuss, but we have been using it as a pretty flexible framework, both in terms of how you set up the mesh and also in terms of how you interact with the software. It allows you to see what's under the hood, which means you can add your own equations, for example, for friction or for sediment transport, and that becomes really helpful. Typical result you will see, this is an example of one of the simulations in terms of hydrodynamics that my group has been performing. In particular, this is work that Wright has been doing as part of his dissertation. And so this is an example hydrodynamic modeling results in the Atchafalaya Basin. And so this is kind of like how you would see simulated one of the campaigns. This is in particular the spring campaign. You see the dates that are going forward in time at the top of the image. And so these are shallow water equation models. So these provide you with essentially what's happening in terms of hydrodynamics in the Atchafalaya Basin. And there's similar and parallel efforts that are ongoing in the Terrebonne Basin as well. So our models for the 21, what did you say? So here we're looking at water velocity. So it's actually a little bit chopped perhaps, and that's why. So the label on the right would say water velocity, and those are meters per second. And so you can see that the velocity essentially goes up to 0.5 meters per second, and that's the yellow. That's where we max out the label. It probably goes up a little bit higher locally, but this is how we set up the color map. And you also see the tides that are propagating in. And so you can kind of see what happens in terms of water velocity as the tides are propagating into the system and out of the system. And that's where the DM data that Alex was talking about becomes really important, because if you run this simulation with the original DM that is available in the area, you will actually not see any of these wetlands being activated, which is a major problem if you're trying to understand connectivity of fluxes with the wetlands, which is what we are after. So this gives an idea of where we are at in terms of the Anuga models that we are doing in my group. So the spring models and the pre-Delta X, so this was the 2016 campaign, and the spring models are complete and these have been calibrated. We are working on the calibration of the fall campaign. The good news is that it doesn't require actually many changes with respect to the spring campaign, except of course for some updates on the friction map. But the models are actually quite solid, and it's good to see that at different time period, actually the model that was developed for the spring campaign works quite well, because that's promising for the application of the model under different scenarios. And so we're still working on the preliminary fall campaign is available, and that's through, if you see the bottom, so the dots indicate when the various data sets you've seen introduced this morning are available. And the blue bar is where we are running the model and whether that simulation is complete or not. So you can see the fall 2016 is complete. the spring 2021 is complete. The time period for the spring was chosen to allow essentially the model to get up to speed and be ready for assimilating the data once the field observations, the remote sensing were available. So essentially we ran the model for a while so that it's ready to go. And then we run the model for when the UAV SAR and the air SWAT and the AVRIS-NG were flown. For the fall 2021, you see that the first part, the first half is available while it's ready. The second part is still pending, and that's because we had a little bit of a small problem in just downloading data for a boundary condition, but that's something that can be solved very quickly. And so that should be finalized by the end of June. And at that point, for these three sets, the main thing we need to figure out is a good way, an efficient way to package the data so that it can be placed at the DAC. And that's the update on my side. And I'm going to pass it one to one.